Similarly, students, I have another question for you, that is, two conducting wires of same material and equal lengths are first connected in series and then in parallel. Find the ratio of heat generated for equal potential difference. So the question is that there are two conducting wires which are having same material and same length and same diameter. That means they both have equal resistance R and R. So first they are connected in series and then in parallel. So the total resistance in series is the simple combination of the two, that is R plus R, so it becomes 2R. But for parallel it becomes 1 upon Rp, so it becomes 1 upon R plus 1 upon R, so it becomes 2 upon R, and therefore R parallel is R by 2, because 1 upon Rp we have to take the reciprocal of it, so it becomes 2 by R, instead of reciprocal of that is R by 2. So we have done that. So now we have total resistance, but the question is you have to find the ratio of heat generated. So we have the formula for heat generated, H is equal to VIT. Obviously we don't have resistance in this, so we can use H is equal to I square RT. But the question over here is for equal potential difference. If we have different we have different combination, that is for series and parallel. If the resistors are connected in series, then the current changes, then current is not equal. That is why it is given for equal potential difference. So in parallel resistance changes, therefore current changes, and in series also resistance changes, therefore current changes. So we cannot apply Joule's law of heating over here. In this formula we have to convert this in the forms of potential difference and resistance. So we apply Ohm's law over here, that is V is equal to IR. Finding the value in terms of I, we get V by R is equal to I, and substituting this value of I in this equation, we get H is equal to V into V by R into T, which ultimately becomes H is equal to V square by R T. Now we have the formula, okay, and now we can apply whether it is in heat energy generated in series and heat energy generated in parallel. So what you get, H in series, that is equal potential difference V square by R, and R is 2R, so we have writing over here 2R and T as it is. In the same way, if it is in parallel, we write V square by, now R is R by 2, so we are writing over here R by 2 into T. Now obviously this 2 is in denominator, so we write it in the numerator, so it becomes 2V square by R into T. So now we have the values of heat energy generated in series and in parallel. We simply apply the ratio, that is HS by HP. It becomes HS is V square by 2R into T upon 2V square by R into T. We take it over here, so HS by HP, that is V square by 2R into T upon 2V square by R into T. This 2 which is in numerator comes in denominator, so it becomes V square by R upon 2 into 2, that becomes 4 into V square by R, this T as it is and this T as it is. So what we have over here is basically the same formula, V square by R into T, V square by R into T, just the 2 has come down over here and 2 into 2 becomes 4. So that is what we have written over here. Now this everything over here, because they are the same values, we can cut them. So what is left over here is 1. So finally what you get is 1 by 4. So ratio of heat energy generated in series and that of parallel is 1 by 4. So we have the option over here, option C, that is 1 by 4. This is how you are supposed to solve. Okay, as you can see over here, this simple numerical, first find the total resistance in series and then in parallel. Okay, then convert the formula of heat energy generated in terms of potential difference that we have done, V square by R into T, and then do the further procedure by simply putting the values of series resistance and parallel resistance. Okay, now I have one question for you that you can do it in your homework. A copper wire has diameter 0.5 millimeters and its resistivity is 1.6 into 10 raised to minus 8 ohm meters. What will be the length of the wire to make the 10 ohm resistance, and how much resistance change of diameter how much the resistance change if diameter is doubled? Okay, so the question is, you have a copper wire and diameter is given, that is 0.5 millimeters. So first things first, you have to convert 0.5 millimeters into meters. Okay, the second thing is, you have been given resistivity and told what will be the length of the wire if the resistance is 10 ohms. So simple, I will give you a hint. You have to apply the formula for resistance over here, that resistance R is rho into L upon A, where rho is resistivity which has been given to you, length that you need to find, area, that is the area of cross section. If you see that a wire is actually a cylindrical shape and the cross section area of cylinder is a circle, and therefore the cross section area, that is area of a circle, is pi r square, that is 3.14 into radius, but you have been given diameter of over here. So first of all, 0.5 millimeters by 2, that will become 3.14 into 0.25 millimeters. Now you have the radius as 0.25 millimeters, convert it in meters, and then use this formula, find the area, put the value of area over here. You have been given resistivity and resistance is given as 10 ohms. So you want to make 10 ohms and then find the length. Okay, we will solve this numerical in the next video.